I have a new project idea for today, and this involves this driveway. And it gets a little bit dark in the evening, so I want to install some lights along this hedge here. And I want that light to be automatically operated by this gate motor. So whenever the gate opens, the light should come on. And then after the gate closes, maybe add in a bit of a delay, and then it turns off. And I have most of the stuff for this already, I think. So let's look at what we can work with. So first of all, I have this gate motor. It says it's made in Italy, so hi to all my Italian viewers. It's a really nice machine, I quite like it. And the reason, well, one of the reason I like it, because it has these end stops. So that detects the end. Well, I guess all motors need to have an end stop. So I think I can steal that contact and then use it as a trigger, because here in this box I have one of the ESP 32s, which is reading the vegan RFID reader, which is on the other side. So that controls the entry to this gate, and this operates the gate motor. So I have power here and everything. So I'm hoping that I can get the signal from here, so that goes up to the ESP, it goes to Node-RED, and I already have cables coming under the driveway. So I think I can get more power and cables into the junction box, and I can run the cable here. And what I'm thinking is, actually I'm going to use my neighbor's fence. It's a fairly sturdy fence, and I've already mounted my charging station and this pole with a camera on it. So I think I'm just going to use something similar, either these type of pipe clamps. It's a very sturdy connection, or one of these connectors to hook onto this railing, and then maybe do a pole and maybe an angle on it, something like that, probably higher. And then I'm going to mount the light here. And for the lights, I have these premium Chinesium LED floodlights, which my brother had, and then he threw them out because they broke. And I thought that the power supply is broken, but actually no, it's the LED module which burnt out. So I managed to get this replacement LED module, which is the wrong size. So this is why it doesn't have the reflector, because it's bigger, so I couldn't get it on. But it works, and it's a free lamp, so I should be able to use it. So there should be two of these. So one would be somewhere up there, and maybe the other one is going to be, I don't know, somewhere here. But before we commit to this project, I think I should test how I can hook up to this motor, and how I can steal the signal, and how that's going to interface to the ESP. But I'm guessing if you're seeing this video, probably it's going to work. Okay, so I've been here before, so I'm quite familiar with this. That's the control circuitry for this motor. So this side is mains, so I'm not going to touch it, but everything here is low voltage. So for example, in these two terminals that you can see here, that's plus and minus 12 volts. So I'm stealing 12 volts here for the ESP, so that powers, well, the ESP and some other stuff. And I can see here that it says common and OP and CL, and actually these are the motors, sorry, these are the end stop, because if you look here we have a contactor, so two micro switches, and that's the thing which detects the end stop. So if I move the door manually, yeah, you can see that it releases the thing, and then it operates the micro switch at both ends. And again, if you look at the control, I'm going to operate this lever again. Yeah, so one of them, well, it's both of the end stops. I'm only going to use one of them. And again, if you look at the wiring, so there is a white wire which is connected to both of them, so that must be the common, and then the switched connection must be one of the brown and the black one. So let's start measuring. Okay, so I tripped the main circuit breaker, so there's no power here, and I want to switch this one to continuity. Yeah, because I want to make sure that actually the ground, so the negative 12 volt connection, and the common is the same potential. And yeah, it is. So that's indeed ground. So again, if you look at this again, so that was the 12 volt input, or let's say power supply. So that probably is coming from this power supply which is up here, so it says 12 volts, and I'm going to use this, the common and the OP and the CL, so it says limit switches. And the Italian engineers added optocouplers, which is probably a sign that I should also optocouple to the input of the ESP, because if anything happens, that can, I guess, damage the input. But yeah, this is a sign that I'm going to ignore. So that's the executive decision that I'm making at the moment. And of course, if the ESP breaks, then we have to deal with that. But let's cross that bridge when we get there. So the reason I did all this investigation, because this is my test board, which is actually running in that box that I just showed you. And as you can see, I have already provisioned an input on this one. So I thought that maybe I'm going to use this input for something, maybe for a doorbell or a motor or something like it, or a position, not a motor, but a position. So it's basically just a push button, and I think there is a pull-up resistor here, and that's probably connected to one of the inputs of the ESP. So I can look and see what that is. So I in EasyEDA, and I just need to find this project. So all projects, and I think it's called the RFID, and that's it. And this is the input switch. So it is connected to A0 of the ESP, but it is connected with a pull-up resistor. I'm not sure why I think the pull-up is usually 4.7K, but it must work because that test board it has the same resistor, and I tested it. So by default, this 10K resistor is pulling the input to high, and then when I connect ground, then it's going to pull it down to ground. So that's going to work, because even the switch is doing the same thing, it's just connecting it to ground. I already checked the code, and actually I can also show you that, but it's already built into the code, so I must have tested it and it must have worked, but I just don't remember it. And the other thing is, in this schematic, I'm using as LM7502 linear regulator, but I think in the actual installation, I use this very small DC to DC converter, but the pinout is exactly the same, and the thing is that it's continuous ground. So it's not an isolated DC to DC converter, so that means that the ground on the motor is the same ground which is here. That means that I can just steal that ground signal from the switch and then connect it to this pin 1. And that's why I'm saying that I don't necessarily need an optocoupler. It will be nice, but maybe we can live without it until I have a lightning strike or something like that. Anyway, that's what I'm going to do. Okay, so let me give you a tour of this box. So you see the cables those cables, so that goes to the RFID reader, and these are the things that are coming from the motor. So this is power, and those are the two cables that go to the relay to open and close it. And that's my ESP. So you can see the small DC-DC power supply and this relay board, and you see a bit of a rust here, so there was some water intrusion at some point. And that's this two switch contact that I can connect to. You see the footprint for the resistor. So I'm thinking, I think I have enough space here to solder everything here in situ, and probably that's what I'm going to do. And I think I'm going to use this opportunity to also replace this 2-channel relay because mostly of the water intrusion, and I don't need a second channel. And I mean, I have 4 outputs here, so yeah, but I also decided that, you see here, this one is a network cable, so I have plenty of cables here, and this, I thought I'm going to use this for power, for mains, for the lights. But then I decided everything here is low voltage, so I'm going to use basically 3 cores from this network cable to bring it down, and for power, ground and signal. So there is going to be 1 channel here and 1 channel down there at the motor. Okay, so we skipped a couple of hours of progress. It wasn't really much progress because actually I was working on this yesterday in the evening. It was really dark, and then it ends up that I have a relay problem. But I managed to get to the same state where I was a couple of days ago. So this is the gate switch or trigger. So then it pulls the relay is on, and then after some time it turns off automatically. I'm not really sure why I've specified such a long delay, but anyway, the thing doesn't mind it, but maybe I can reprogram it. And the issue was that, this was the original relay which had the water intrusion, so this pin got corroded quite bad. So what I ended up doing is I replaced it with wires, and I created another piece of jumper wire and I wired it up. So as it turns out, it really matters what type of relay you are using. So I have used 2 more relays which didn't work with this ESP, and I ended up going back to this one because I don't have a single channel relay. I ordered a couple from Amazon yesterday, but it would take a month to arrive. So I'm going to use this 2-channel one, only going to use one of the channels just like before, and but at least this is working now. So since I was talking about the issues with the relays, let me just show you the 3 relays that I used. So this was the original relay, and I happened to buy this years ago, and I think I bought a batch of 2-channel, 4-channel, maybe a few 8-channel relays as well, and they always worked. I never had any issues with them. I didn't even notice that there are multiple types that not all of them work. And so I, in order to save some space, I wanted to buy some single channel relays. So I bought these on AliExpress, and these did not work. And what I noticed that, okay, if you look at these, you see these 2 black 4-pin chips there. So those are optocouplers. So they create an isolation between the input and the relay, which is always good. And this one didn't have an optocoupler, which is, I don't think it's really an issue, but I thought that maybe that contributed to the problem. So if I would connect to the ESP, the relay would be just on, regardless if the output is 0 or 1. And to be honest, I can't really figure out why it is. So maybe the floating nature of the output, because I connect this directly to the pin of the ESP32, and yeah, so these modules work and these modules don't work. And I thought maybe that's also related to the fact that you can switch this to work with active low or active high signal. So at the moment it's configured for active low. I think this is what these jumpers are for. So I bought this relay in a local shop. So as you can see, it has the optocoupler, and on the other side it says low voltage trigger. So this is also active low, but this didn't work either. So the problem is focus, yes. So the problem was that, well, the symptom was the same. So I would connect this and it would be on all the time. So that's why you have seen just previously that I ended up using the same 2-channel relay, even though I'm only using 1 channel, but I put some orders in AliExpress for a single channel relay. So I'm thinking that the point is that buy ones which have the additional jumper, so it can be used as an active high or an active low connection as well. But also what is crucial is that I did check the listing that, well, I put the order to for. It says that active low, sorry, the low signal is 0 volts to 2.5 volts, and sort of like 3 volts onwards, it's considered as high, which is a good thing because the ESP32 is a 3.3 volt chip, which means that even though that the outputs are, or the pins are 5 volt tolerant, but when you switch them to 1, the voltage is going to be 3.3 volts. So you have to make sure that you buy one where the active signal goes all the way down to 3 volts, because otherwise it might work with older Arduinos which work on 5 volts, but with the ESP32 or ESP8266, the output is 3.3 volts, so it needs to trigger on 3.3 volts. So anyway, that's the learning. So buy these ones with the optocoupler and the additional jumper for active high, active low selection, and make sure that you check the listings that what voltage range the circuit considers as an active signal, like a high signal or low signal. And by the way, this is the Arduino code for this project, and as you can see, check the analog input and post changes to MQTT. So it checks the analog input from time to time. I think globals, analog rate, no, settings, it must be in settings. Analog every 250 milliseconds. Maybe I can increase that to 500, and then it checks, and if it's not the same as the last one, then it publishes either 1 or 0. And there is also an input topic, so it's going to be /input topic where this input value is posted to. Yeah, let me just quickly rectify this timing issue. So just refresh the firmware. I changed this value, which is the pulse delay in the code. So that's the relay, and that's the thing. So gate, that's it. That should be a short enough impulse for the motor to turn on and off. Okay, so let me document this for myself as well. So these bunch of cables here, you see that's the network cable which goes down to the motor. This white cable is not get used, so I'm just going to tuck it back here. And so yeah, a relay that will be connected to these 2 lines, which again go down to the motor. That's the original connection, which gives the signal to the motor to start going in and out. And then so the green one, that's going to be from the limit switch, which is connected to the switch input. That's the input line, which is connected to A0 of the microcontroller. And then I figured that I have created this block of 3 terminals for the NeoPixel LED, which I never use. And this has 5 volts and ground. So this is ground, this is 5 volts. So that's going out on the orange and the white orange, again down to the motor where I'm going to have the relay to turn on mains. I think I have everything in here. So I want to do the wiring downstairs, and then we can test it on battery power to see if it works. Hey guys, and check this out. I think it is working. So it is all wired up to this switch. You can see the green wire. Yeah, I got my hand. So, and that goes up to the input, and that's the thing to watch for. Damn it, this limit switch. And if I do this, Yeah, so it's working from battery power, and now we should check if it's working from mains power as well. I mean, from the 12-volt adapter. But if this signal goes through, that means that the grounds are connected and we should be fine. So let me just put the power back and check. Okay, so I'm going to turn the power back. You should hear a beep, and if everything goes wrong, no smoke is going to come out here. Okay, so far so good. Let's look at my phone. Okay, you won't be able to see this because my hand doesn't reach that far, but it is working. I'm getting the same signals. So anyway, you can't see it, but anyway, it's working. So let's pack up everything because the sensor part of the project is done. Okay, so let's do a final test because it's entirely possible that I'm going to fry the ESP once I have the, not the mains, but the 12 volts and everything switched on. So let's switch on the circuit breaker first, and we should hear a beep. Oh, 2 beeps. Okay, that was good. Good sign, good sign. Nothing is smoking. I mean, I won't be able to see anyway, but nothing is short-circuiting. So let's try the app first. Okay, so you watch that one? Oh yeah, it is working. Okay, so I'm going to close the door now. Okay, so actually the limit switch is off when the door is closed, so means that the limit switch is on when the door is open. Okay, that's good. So I'm going to remove this manual key. So the motor is now engaged, and let's open it. Yeah! So the limit switch is on, meaning that the door is not closed. Okay, so I'm going to do it one-handed. Yep. Perfect. Okay, time to pack up. I really love this place where we are going. It's just a steel yard in the middle of nowhere, and it's about 5 minutes drive from where I live. So there is this green area between the highways here, and there is this single lane road, and then you just end up in this old building, which, I mean, you know, they are just selling steel. It's lovely. There are a couple of old buildings here. I think most of them are abandoned. And that's my steel yard. The road is awful, but yeah. And I think probably I have no idea where I'm going to spark. So since Friday wasn't a complete brain drain for me, and we have all the materials here, so I think I should get the welder out and then just weld the arms for all the lights. And I'm thinking that I have these tubes, 2 meter each. So I'm thinking that for each of the lights there is going to be like a 2 meter section and then a 1 meter section at 45 degrees. And there is going to be a mounting bracket on at the end of it. And I think that should do. So this is how it's all going to look like. So that's the long section, that's sort of like a vertical post. So that gets clamped to the railing. And there is a 45 here. And so that would extend in and out. And at the end, this is the 2 plates that I cut. And then, so that gets welded on the end of the pipe. And then I will have the 2 holes and mount the premium Chinesium LED light on it. That's it. Aziz light. If you know this reference, you are lucky. Okay, it's one here, one there. And one here and one there. Center punch from AliExpress. But to be honest, it works great. Okay. Let's drill these. get set up for welding. Okay, so I usually weld on this thing, but then it gets a little bit wonky because then the rod just, the pipe just starts to roll down. So I think I'm going to weld here on the floor, or at least maybe I'm going to tack it here, and then put this thing under it so I don't torch the concrete. But I think we are ready. So we need gas. It's really difficult one-handed. Okay, we can turn this on. And so this is 2 mil. I think I need 80 amps, something like that. Well, not that it's going to be visible, but lining up the two pipes actually resulted to almost equal posts. I mean, they are not wonky at all. Not that it's going to be visible, but anyway. And that's what I said. So that's the correct one. And I cut this the wrong direction. Damn it. So now it needs to go to the bend, so it needs to be cut like that. By the way, that's how the butt joint looks like. It's not nice, but I think it's good enough for my first try. I mean, first try welding pipes. So let's continue with the questionable practices. So the ground lead does not reach until the end of the pipe, and the clamp doesn't open up so you can clamp on the pipe. So now I clamped it on the magnet. Yeah. And that's the open end where I need to weld on that plate. And I think I just need to just hold it and tack it from the underside, and I guess I was just going to flip it over and then weld it. And I'm going to leave this end part here because I'm hoping that I can thread the wires through the whole tube So it's just going to come out here. At least that's the plan. So a few more days have passed, and actually, oh, can you see that? No, you can't. Anyway, so I had the first coat painted on the these new posts, and yeah, I'm ready to give it another coat. I'm just using a normal paintbrush because I wanted a really thick coat on it. Just make sure that it's going to, stay there for a long time. And yeah, probably I also need some protection for the clamps so it doesn't scratch the paint. But yeah, let's put the next coat on. I think I'm going to just time-lapse this because otherwise it's a really boring task, but I have some free time now at work and I might just use that, and probably I should be done in an hour or something like that. Okay, so I was digging around, as it turns out I have some cables, leftover cables that I can use, and I specifically wanted to use these, so 3-core 0.75 mil. This should be more than enough for this application, and it means that it's fairly thin, so I should be able to get this through the conduit. I don't see the markings on this, but I think it's the same. So you can see it's 3 times 0.75. So I have no idea what gauge that is. Maybe I'm just going to overlay that. But it's a fairly thin cable, but at least it should be easier to work with. I just need to figure out if I have enough length. So I think I'm going to roll this out and measure. And this is why I was so critical about the cable, because I wanted to make sure that it fits down here. so I can feed this all the way through the conduit, and there is, you know, plenty of space, and I think I should be able to get through that band without any issues. Okay, I think this cable gland is rubbish because it just spins freely. So probably the threads are all chewed up. But it holds firmly already. So I think, I don't know, I'm going to leave it as it is. Maybe I will just, if I need to go to get some more cables, then I would buy some cable glands and replace it. But let's just leave it as it is. And this installation got chewed up as well. It's not even Chinesium parts, but also Chinesium assembly. I think I'm going to feed the lamps from the same circuit as the gate opener, which has a GFCI. So if there is anything wrong with these lamps, then it's going to trip the breaker for the gate as well, which is going to be painful. But at least I would definitely notice that something is wrong. Okay. First one is done. I'm not sure if it's necessary, but I'm using lock nuts just to make sure it doesn't come undone. And by the way, look at all this gunk that came through this pipe. All throughout this wire. Oh geez, I need to clean this off. I couldn't really get the camera for you to see how I'm fixed this, but I mean, it's not really rocket science. So you can see that's my pipe, and this is just a piece of plastic pipe, and that's the cable tie, not cable tie, pipe clamp. You can see the fence on the other side, and it's very rigid now. And the next one is here. So, oh man, it's on. So yesterday when I put the camera on charge, I continued the installation, and we have one more done. So we have both of them installed. And I have also done the cabling. So that's the cable tie. And well, that's the end of the pipe. And I decided to add this loop here because I was thinking that water might run through this. I don't want that same water to run into the conduit, so that's why I added this sort of this loop here. But anyway, it continues, and it's cable tied all the way to the end of the bottom of the fence. And I think we have, yeah, the second one comes in here. So it goes up the same way after the second lamp. Yep. And going back down, it continues along the bottom of the rail, and it comes to this junction box. And I had a spare conduit here, an empty one, so I'm feeding the wire in, and unfortunately I have to do this Wago connection here. So this is a very simple snap-on junction box. It's IP45 rated. So there is no sprinklers here. There is not an awful lot of rain. I think the trees above protected, so it should be good enough, I think. So if you remember a couple of, well, maybe 10-15 minutes ago, I said that from the ESP, which is up there, I connected orange and white, which is power 5 volts, so that is connected to the DC input of this single relay. So by the way, these are the AliExpress relays I was talking about, so now they arrived. And white blue is the second output for the lights. And if I get my phone out, I have this test thing. It says driveway lights, and now it is working. Oh, by the way, there is an indicator already, so you can see it works. So the low voltage side of it is done. Now I just need to wire up the mains, and then it should be good. I try to hook onto the first 2 wires, so that's mains coming in for the motor, and I think the ground is probably mounted to this chassis, so I need to find that one as well to create a common ground. But yeah, I'm going to do this off camera. And just before the sun is about to go down, so that's the lights. Relay comes on, and the lights come on. And if I press it again, oops. Check this out, this premium Chinese relay. So the light is off, and I can turn it on, and now the light is on, and I turn it off, now it's off, on, and then it stays on even I've turned it off. So what happens, I do this, the light goes off, the contacts of the bloody relay get stuck on, maybe because of the inrush current of the LED drivers. But I mean, this is the 5th time that I turn this on. Absolutely useless piece of shit relay. I'm going to swap it out with another one because I bought 5, but hopefully it's going to be just a one-off issue. I swapped out the relay, and it seems to be working fine now. I think you can see the illumination in the background. So hopefully it was a one-off issue. But anyway, this seems to be working. So it's getting, no, it's stuck on. Bloody fucking, sorry, the English. Ah, Jesus Christ, what I'm going to do with this? This is completely unusable like that. Okay. It's getting dark. I'm going to pack up, and I'm going to deal with this a little bit later. So I went online yesterday and asked around, and my suspicion was correct that the relay which was on this board is probably like very low quality, and the high inrush current of the LED driver just fused the contacts. So the battery cut my thought in half, and I don't remember what I was saying, but what's important is that I put a new relay into the motor, and it is working. I mean, you can't really see anything, so I just quickly remove the box, change the relay module with the new one with the replaced relay, and yeah, it is working now. So it's still fairly light, so I think I'm going to do the logic, and then we can give this a test in the evening. So let me do the coding for this, because there is still daylight, and if I can get the code working, then maybe we can test it today. So we'll see. So first of all, I'm going to do just in Node-RED everything with standard nodes with least amount of coding. But what I need first is I have in the automation engine, I have a very simple state machine which says if the daylight is on or off. And I think I already have, so this is the output of the automation engine. And just to go back to the rules, so I have a set of rules which says that washing man's daytime starts. So if the light level is greater than whatever value, then the daytime starts, and then nighttime starts. So in each case it outputs a control which says nighttime starts and daytime starts. So that's what I'm going to be looking for, and I'm going to store it in a global variable. So nighttime starts, daytime starts. Okay. So change. So nighttime on. So global night. I'm just going to call it nighttime. And I'm going to set this to, where is Boolean? To true. And nighttime starts. So that's the second port. So nighttime on. And there is going to be another one which says nighttime off. So global.nighttime is false. And that goes to the second one. So that takes care of the logic which is going to tell me if it's like nighttime and I need to turn on the light, need to turn the lights on. So it looks like that most of my logic for the gates is here in the access control. So I'm going to find a suitable place for this to have, and it looks like that I have a bunch of stuff here. So probably I'm just going to add it down here. So maybe I'm just going to put it there. And comment. I'm just going to add something here so it will be easy to find in the future. So comment driveway lights automation. Okay, so everything is going to start with the MQTT node, which is I'm just checking my phone. So that's the limit switch of that comes from the gate motor. So it is local broker single topic, and the topic is RFID/gate/input. RFID/gate/input. Okay, and that's going to go into a switch node which says limit switch state. So if the value is 1, that means that it is open, and if it's 0, then the gate is shut, closed. Okay. By the way, let me just deploy this. And then I'm going to have a switch node which checks the nighttime. So, oops, not. Did I set global previously? Automation. I'm just not sure. Let me check. Global. Yeah, global. Okay, so that's good. Driveway. So if the global nighttime is true, so if the limit switch is on and the nighttime is true, so the gate is opening or it is open, then we want to send an MQTT message out. And that's going to be, I'm just checking my phone where I have all these topics configured. So that would go into RFID/gate/relay2. And let me just add a change node just to be sure. And the payload is going to be equal 1. Okay. So if the input says that the the switch is 1, then we check if it's nighttime, and then we only turn on the light if it's nighttime. Yep. Okay, and if the limit switch is off, then we set a delay. So once the door closed, and we set this to, let's say, 2 minutes, and then we turn off the relay. Off. So we send the 0 out. Actually, let me do this, less amount of nodes. And also I think I want to add a change node here. So that's a reset. So the message.reset equals 1. And that just resets the off timer. So if I reopen the gate within the 2 minutes, then the light will not turn off after I closed it, 2 minutes after I closed it for the first time. I did this for some of my other nodes, and this seems to be working fine. So if you send a message.reset with any value to the delay node, then it just deletes everything. So the message which is waiting here for the end of the delay is just going to get forgotten. And that should be it. So the limit switch turns on, but it's nighttime, then nothing happens. And if it's closed, then, well, it will send a close message anyway, but it's not going to make a difference. But if it's nighttime, then it turns on, and then after the gate closes, after 2 minutes, it's going to send a turn off signal. And that should be all, to be honest. Everything is connected, so RFID/gate/input, RFID/gate/relay2, in case I mistype anything, but I did not. And this is called night time. And yeah, so night time is actually doesn't exist yet, because yeah, it will only get set when it transitions between those thresholds. So this one is going to be false. So it's good that I only check for when it's true, because if it's false or it doesn't exist, then it's not true. So then it's not going to allow the message to go through this node. So I think that should be it for now. Most ugrik a majom a vízbe. Nézd.
Csezd meg.
And yes, it worked perfectly, and it pretty much lights up my entire driveway all the way to the back, even though the last light is sort of like halfway, but it's great, just the way I imagined 3 months ago. So let's do a quick post-project review. I think I started working on this, well, the idea probably in the summer, but I sort of like actively worked on it in the last couple of months. No, last month, I think. So it was about month and a half. I managed to reuse loads of the stuff that I had on home. So the lights are obviously stuff from my brother, which he didn't want to use anymore. And then, so the only thing I bought is basically, I think probably 20-30 bucks I spent on the steel, and probably another 20 on cables that I didn't have. And the LED panels were maybe like just a few bucks each. So all in all, the project was quite cheap, I would say. And we did manage to get most of the original requirements done, so that's good. So on time, because then the cold weather and also the dark weather started, so that's good. So probably the only ticking time bomb is that relay. So we'll see if it goes bad, then I need to replace it. I do have these SSD modules, which I think are going to be better, but I don't have a single version of them. And I don't think that the dual SSD, not SSD, SSR, single solid state relay module will fit into that very small project box, but we'll see. But I guess that will be all for this video. Thanks for watching, and hopefully see you in the new one.